Hi, my name is Emma Hamby, and for my senior thesis for Central Magnet School, I decided to make a reef-friendly sunscreen, which I'm calling Reefriend Sunscreen. And so what started this whole process was the fact that when I lived in Australia, I noticed the harms of the degradation of coral reefs when I was swimming in the Great Barrier Reef, and so I was interested in finding a solution to that. Also, while I lived in Sydney, Australia, there was a lot of sun protection campaigns that were going on that made me a very aware person of sun protection and the presence of skin cancer in that nation, but it's also prevalent here in our own. So the overall purpose is to promote sunscreen usage that is safe and environmentally friendly, but it's also to just promote sunscreen as a whole, because a lot of people who are interested in protecting the environment are not interested in using sunscreen, potentially for the environmental reasons, but also potentially because it's not cosmetically appealing. So I wanted to combat both those sides of it and try to make a sunscreen that was cosmetically appealing as well as friendly to the environment. So one of my main goals was to reduce the effects that humans have on coral degradation, as the coral reefs are one of the world's most biodiverse ecosystems, and to promote environmental consciousness and to protect users from the sun and thus prevent skin cancer. As I mentioned earlier, it's a prevalent issue currently. So through my research, every source that I found said one central message, that was sunscreen is important, whichever brand you choose, and it's very important to keep using it. However, as they took a step further to decide which sunscreens were the best to use, most sources agreed that inorganic-based sunscreens were a lot better for the environment than organic-based sunscreens. Organic-based sunscreens include the chemicals oxybenzone, avobenzone, stuff like that. Oxybenzone being particularly problematic, and the state of Hawaii even banning it in sunscreens. However, some sources claimed the contrary, but that was due to the fact they were funded by companies such as Neutrogena that promoted sunscreens that contained those chemicals, so there's a little bit of a conflict of interest there. But overall, most sources claimed that inorganic blockers were more environmentally friendly and sometimes more effective than organic blockers, which led me to decide to make an inorganic-based sunscreen. And I decided to take 4 different approaches and make 4 different prototypes. I would make 2 that were based off of a beeswax emulsifying base, and 2 that were based off of just an emulsifying wax base. And from those 2 prototypes, I would use 2 different active ingredients: titanium dioxide and zinc dioxide. Now, zinc dioxide was what the recipe I found online called for. However, titanium dioxide is what my research showed was less harmful to the environment. Titanium dioxide and zinc oxide are both inorganic, so they're both less harmful than oxybenzone. However, some said that zinc was still problematic, so I decided to try and explore titanium and see which option was better after my testing. So for our current and past solutions that I was looking at to try and gain some insight from, along with Hawaiian Tropic and Copper Tier, sunscreens such as Banana Boat used oxybenzone and avobenzone, so I knew those were not going to be helpful in guiding me, but I knew that was something I could try and stay clear of, were those ingredients, and make a sunscreen that was better than that brand of sunscreen. Another sunscreen brand called Sunbum recognized the harms of oxybenzone, however it still used avobenzone, which research shows is also problematic for the environment. So I decided to keep doing some digging, and I found there's a sunscreen called Tropic Sport that used the inorganic blockers like I want to do. However, it left the white residue on the skin, which made it cosmetically unappealing and thus deterred users from wearing it. So for my prototype, I decided to work in a laboratory setting with my mentor, Dr. Amy Phelps at MTSU, and I worked with her in order to make the best sunscreen possible. Originally, we had troubles with different ingredients because we used a solid parafilm instead of a liquid paraffin as the recipe called for, which caused our sunscreens to be chunky and not appealing at all. But we pushed through that, and we worked together to try and find another solution, buying liquid paraffin, and we made sure that all ingredients that we used were either cosmetic grade, medical grade, or food grade. That way we can ensure that it'd be safe for users to wear. So here on my poster, I have some pictures that are a little bit difficult to see probably for this camera, but I do have my prototypes right here next to me, which we'll get onto that in the next portion. However, I did want to talk about my testing really quickly, because it was really important that I could find a testing method that had some quantitative data as well as qualitative data, because looking at the sunscreens, I knew which products I wanted to use based off of their cosmetic appealingness and some other qualitative data about it, just how easy they were, how nice they looked before application. But we wanted to make sure that there was data to support which active ingredient was actually better. So we decided to use a UV vis spectrometer to measure absorbance, and the way we had to do that was to dissolve sunscreen in isopropyl alcohol. We dissolved 0.002 grams of sunscreen in 100 milliliters of isopropyl alcohol, and we ran 3 vials through the UV vis at various wavelengths. Now, we intended to do this for all 4 prototypes, as well as 3 off-the-shelf sunscreens that included a 15 SPF, a 30 SPF, and a 50 SPF, in order to plot a graph and figure out an estimate SPF where our sunscreen would lie. However, unfortunately, many of the sunscreens did not actually dissolve in the mixture, and they remained suspended in solution in tiny little chunks. So that would not have run through the UV vis spectrometer and returned a viable result, because it would have been essentially measuring just the absorbance of the isopropyl alcohol, which is very little because it is clear. However, it did work with our emulsifying wax base. So we went from that starting point and we decided to still test it and run it through the UV vis spectrometer, which led us to a conclusion that the zinc base was a worse sun protector than the titanium base because it had lower levels of absorbance. So the titanium, we know now, is the most protective out of our 4 prototypes. And the difference between the beeswax base and the emulsifying wax base, we could not find a difference with the measures of absorbance because the beeswax base did not run through the UV vis. However, we can compare the cosmetically appealing factor and decide overall that we think titanium dioxide is our best product in the emulsifying wax base because it was the most sun protective for what we could measure, and it was also most cosmetically appealing. Now, I do have my 4 prototypes right here, and I decided I will show off the beeswax base first because, like I said, it's a little bit less cosmetically appealing. And it had some separation throughout it. Now here is the second beeswax base. This one's the titanium dioxide, and as you can see, it's a little bit more white in coloration. But like I said, these I decided not to use specifically because it was not cosmetically appealing, and furthermore because it smelled kind of bad, which no one wants to put that on their body. Now for our emulsifying wax base, we have 2 really nice samples. We have the zinc, and we also have the titanium dioxide. Now here you can see this right here is the zinc, and as I rub it in, it goes in pretty smoothly. There's a little bit of excess on my hand right now, but overall it's not too bad in the coloration. The titanium, however, does remain a little bit white. Overall, both actually go in and rub in pretty nicely overall. They're not extremely white in coloration. There's still white on the sides, but that's just the excess. So I was really proud of these prototypes, but the one thing that I wanted to try and do was to combat the white residue that it leaves behind. And so my idea was to use iron oxide, and iron oxide I researched and it said that it would not harm the environment, which I was very thankful for. Iron oxide is used to dye cosmetics brown, and I wanted it to have a color matching appeal similar to cosmetics on the market such as foundation or concealer. And so I attempted to dye the sunscreens brown and make them skin tone matching. However, the iron oxide did not dissolve completely in the sunscreen, which was another issue that we ran into. The sunscreen that we created with the iron oxide ended up being a little bit more gray than brown, and so the final product is our titanium dioxide emulsifying wax base that I applied earlier, and all in all, it does not leave as much of a residue as some of the on-the-market brands do, which is something I'm really proud of. But in the future, I encourage other producers to explore more into the color matching effects of sunscreen and to encourage people to wear sunscreen, especially men, because I know color matching sunscreen might be a deterrent for some men because they might think it's too similar to makeup products and cosmetics.